In this video, we're going to graph linear equations by using intercepts. So before we actually begin talking about how to graph using intercepts, we need to talk about how many points we actually need to graph a line, because that's why this strategy exists. So realistically, let's just try it out and see how many points we actually need at a minimum to draw a line. So here if I plot 1 point, so say I have a line that goes through this point. If I try to draw a line through that point, I could draw this line in blue, this line in green, this line in yellow. So 1 point isn't enough to actually allow us to draw a single line, because if we have 1 point, we can essentially draw an unlimited number of points through that line. So it's not 1. We know that for a fact because we can see that we can draw multiple lines if we have a single point on that line. But now let's try and let's go to 2. So here if we plot 2 points, I got point number 1 and point number 2. So let's see how many lines we can draw through these 2 given points. So here, if I draw this line here in blue, I connect the 2 points. And then if I try to draw a different line, I discover that I can't draw a different line. Even if I try to connect the points in a different order, I still draw the exact same line. So to answer this question of how many points do we need to actually graph a line, we need 2 points. If we have 2 points on that line, we will be able to create an accurate linear graph. So now, with that being said, today we're going to focus on 2 very specific points of a line. And these points are called our intercepts. So today when we graph, we're going to find our x-intercept and our y-intercept, plot the points, and then use those 2 points to help us draw an accurate graph. So to begin, we need to define what these 2 points are. The x-intercept is the point, and notice that it's a point. You need to know that the x-intercept is a point. But the x-intercept is the point where the graph, so our line, crosses the x-axis. So x-intercept is where we cross the x-axis. And remember, the x-axis is this horizontal number line here. So the point where our line in purple crosses the x-axis is called our x-intercept. And on this particular graph, it's the point x is 3, y is 0. So on this graph, this is our x-intercept point because it is the point on the graph where we cross the x-axis. Now on the flip side, if we define y-intercept, the y-intercept is the point, so this one is also a point, where the graph crosses the y-axis. Remember, the y-axis is our vertical number line here, and the y-intercept is where we cross the y-axis, which we can see right here in our point in red, is where x is 0 and y is a positive 4. So what we're going to focus on in this lesson is how we can find the x and y intercept in different ways, and then how we can plot those 2 intercepts and use them to create an accurate graph of our line. So now that we know what the x and y intercept are, we're going to talk about how we can find them algebraically. If we don't see the line on a graph, how do we actually find these? So in order to start, let's focus here on the x-axis, because we know that the x-intercept is where we cross the x-axis. So let's take a look at all of the points on the x-axis. So here, if I label some of these points on the x-axis, I find that this is the point x is -5, y is 0. Here, x is -2, y is 0. X is 1, y is 0. X is 4, y is 0. And what I start to notice is that I notice that all of these points have one thing in common. All of the points on the x-axis have a y value of 0. And I'm going to use that to my advantage. So The x-intercept point is where we cross the x-axis, and every point on the x-axis has a y value of 0. So what that tells us is that our x-intercept point of a graph is actually found when y is equal to 0. So our x-intercept point is a coordinate point, and in that coordinate point we know that y is going to be 0. So that's what we know about the x-intercept point. And we'll come back and find that in just a second. But our x-intercept point is where y is equal to 0, and we need to find the x value that goes with it. So that's the first piece we're going to look at there. Then, if I flip this around, I'm going to take a closer look at the y-intercept point. So here, the y-intercept, let's focus on the y-axis because we know that the y-intercept is where we cross the y-axis. So this point here is x is 0, y is 6, x is 0, y is 4, x is 0, y is 2, x is 0, y is negative 1, x is 0, y is negative 4, and x is 0, y is negative 7. So I'm just looking at a bunch of points on that y-axis. And what I notice on the y-axis is that all the points on the y-axis have one thing in common. And all of these points on the y-axis have an x value of 0. So that's telling me that my y-intercept point, since it's found on the y-axis, my y-intercept point is found when x is equal to 0. So my y-intercept point is a coordinate where x is 0 and I need to find y. So now we're actually going to take this knowledge and apply it. So notice here that our x-intercept point can be found when y is 0, and our y-intercept point can be found when x is 0. So we're going to use that to our knowledge. So I'm going to come back up here to the very, very top, and what you'll notice here that you may not have noticed before is that I actually have an equation here. And this is a linear equation. We can see that we don't have any exponents in there or square roots or x's in a denominator, so this is a linear equation. And what we're going to do with this linear equation is we're going to find its x-intercept and find its y-intercept by using the notes we just took. So here we can see that our x-intercept point can be found when y is equal to 0. So essentially we're trying to fill in the rest of this coordinate point. We know that y is 0 and we need to find x to find our x-intercept. So we're going to take this original equation here, and since we know that at the x-intercept point y is 0, we're actually going to plug that in for y. So here we're going to take that equation, so we have 2x minus 3 times 0 is equal to 12. And then we're going to solve this equation for x. So 2x minus 3 times 0 is 0. I know that because that's 0, I really don't need to write that in, so I can just write 2x. And then I can write 2x is equal to 12. Divide both sides by 2, and I find that x is equal to 6. So what this tells me is that when y is 0, x is 6. So my x-intercept point is occurring at the point x is 6, y is 0. So that is my x-intercept point for this particular linear equation. And then if I switch gears, I'm going to focus on finding my y-intercept point. So my y-intercept point is found when x is equal to 0, and we're going to take x equals 0, substitute it in for x, and find the y value that pairs with it. So here we have 2 times 0 minus 3y is equal to 12. This is an area where students often make errors, so we can rewrite this subtraction as plus negative 3. Now I know that 2 times 0 is 0, so this is really a negative 3y is equal to 12. Divide both sides by negative 3, and I find y is equal to negative 4. So this tells me that when x is 0, y is negative 4. So my y-intercept point occurs at x is 0, y is negative 4. And now at this point, I have 2 points on my line, and I know that I need 2 points to graph an equation correctly and accurately. So all I'm going to do is connect my 2 points, extending with arrows all the way through the coordinate plane to communicate that that line continues. But there we have it. So if we can find our x-intercept and find our y-intercept, we can create an accurate graph of a linear equation. So now we're going to just try this same concept with a couple of different examples. So we're going to find the x and y intercepts of this equation here. So the first thing I'm going to look for is my x-intercept point. And remember, my x-intercept is a point, and what I know about that point is that the y value is 0. So I need to find x, but I know that the y value is 0. So in order to find my x-intercept point, I now need to plug 0 in for y. So I have 0 equals 1/2 x plus 3. And what I need to do here is I need to rewrite this equation and solve it so that x is by itself. So what I'm going to do first is I'm going to subtract 3 on each side so that these undo each other. So now I have -3 is equal to 1/2 times x. I then am going to divide both sides by 1/2. So here I have -3 divided by 1/2 is equal to x. Need a little bit of extra space here. I know that I can rewrite this as -3 times 2/1. And if I multiply that out, what I find is I get -6/1. So x is equal to -6. So what I've found here, I can now put back into this original point, and I know that the x-intercept occurs when x is -6 and y is 0. So I can go to that point on my graph and plot it. So here I have x is -6, y is 0. That is my x-intercept point. Then from here I need to find my y-intercept, and what I know about my y-intercept is that at the y-intercept point, x is 0 and we need to find y. So what we're going to do here is we're going to substitute in 0 for x and find the y value that corresponds with it. So we have y is equal to 1/2 times x is 0 plus 3. Well, 1/2 times 0 is just 0, so I find y is equal to 3. And then I can substitute that value into my point. So I find that my y-intercept occurs when x is 0 and y is 3. So x is 0, y is 3. And then my last step here is simply to connect these 2 points and to create an accurate graph. So I take those 2 points, I connect them with arrows extending through the coordinate plane. And final example here, again, we're going to find the x and the y-intercept of the following linear equation. So here it is right here, it's 4x minus 5y is equal to 40. So again, we're going to start with our x-intercept, and remember with our x-intercept, our y value is always 0, and we need to find the corresponding x value that is with it when y is equal to 0. So we start by substituting 0 in for y, so we have 4x minus 5 times 0 is equal to 40. Well, 5 times 0 is just 0, so I really have 4x is equal to 40. Divide both sides by 4, and x is equal to 10. So what I've found here is that my x-intercept point occurs when x is 10 and y is 0. Now what I notice when I look here is I notice I don't have 10 slots going from left to right. So what I'm going to do instead is I'm going to actually label these by 2. So 2, 4, 6, 8, 10. I'm going to plot that point. At the point x is 10, y is 0. Now from here I need to find my y-intercept point. So I'm going to start by remembering that this is a point, and what I know about this point is that the x value is always 0, and I need to find y. So what we're going to start with is we're going to substitute in 0 for x, so I have 4 times 0 minus 5y is equal to 40. Then here I'm going to utilize keep change change to rewrite my subtraction as plus a negative. Now from here I know that 4 times 0 is just 0, so I know I'm really left with -5y is equal to 40. Then I need to divide both sides by -5, and I find that y is equal to -8. So I know that my y-intercept is occurring when x is 0 and y is -8. So here I notice I have 1, 2, 3, 4, 5, 6, 7, 8. So I can fit my point down here at x is 0, y is -8. And now that I have my 2 points plotted, in order to create an accurate graph, all I need to do is connect the 2 dots and form a line. So I connect the 2 dots and form a line, extending all the way through the coordinate plane with arrows on both sides.